Thank you for tuning in to the Furnaces North America presentation, Heat Treat Automation, What the Business Owner Needs to Know. My name is Alex Kominek, and as an employee of Surface Combustion, I have been working in the heat treating industry for over 24 years. I have been in positions starting at the field service level and ranging to product engineering, project management, and I am currently the business unit manager for the Standard Products Division at Surface. Today's presentation will focus on the automation of batch integral quench furnace lines, and specifically on sizes large enough to require a charge car. We will discuss the different levels of automation and control from the factory floor to the overriding control systems. We will also walk through several topics that should be considered when determining if and when a batch integral quench furnace line should be automated. The first step in describing an automated line is defining the movements and process of automation. We will first focus on the mechanical movements within the batch integral quench furnace. Although most of the furnaces manufactured today include internal handling systems, older furnaces and some still manufactured today use charge car handlers to transfer loads from the furnace chamber to the quench elevator. All motions were controlled by operator push buttons. This included opening the vestibule and furnace door manually and charging the load with the charge car handling system manually. Load quenching was also performed manually with the charge car handler. This could result in varying furnace to quench times depending on the speed of the furnace operator pressing buttons and actuating handles. As the video plays, you will see the charge car pushing the load into the vestibule. Once the load stops, the vestibule door must close before the next motion is initiated. The operator will often wait a moment or two to assure the atmosphere stabilizes before opening the furnace door. At this point, the operator will open the furnace door and move the workload into the furnace chamber before retracting the charge car handler and closing the furnace door. At the conclusion of the heating cycle, the operator will manually open the vestibule slot door and the furnace door and use the charge car handler to transfer the load from the furnace to the vestibule elevator for quenching. The result was a slow, non-repeatable quench time and inconsistent material properties. The inclusion of the rear handling system allowed the internal motions to become part of the program cycle. This was a progressive step in the automation development. The furnace operator's only responsibility was to place the load into the vestibule and start the cycle. Relays and timers would actuate the door and rear handler to transfer the load into the furnace, back into the vestibule, and down into the oil quench. As this video plays, we pick up with the load in the vestibule ready for transfer into the furnace chamber. The furnace PLC is controlling the mechanical motions and has already opened the furnace door and has initiated the rear handler motion to pick up the tray with the workload. As the load stops in the correct position, the furnace door close motion is actuated. At the conclusion of the heating cycle, the PLC will signal the furnace door to open. Once opened, the rear handler will push the workload onto the quench elevator and retract into the home position. At this time, the furnace door will close and the quench elevator will lower into the oil. The programmed movement provided for repeatable furnace to quench times, improving part quality and consistency. Further advancement in controls replaced the timers and relays with PLC hardware and software. This presentation will focus on the next level of automation, which includes an unmanned charge car delivering loads between the heat treat equipment components, including BIQs, temper furnaces, washers, tables, and other components. The programmed automation includes setting a path for the load to be processed from beginning to the end. The plan would also include recipes for each step in the path. This may include pre-washing, preheat, carburizing or hardening, post-wash, and tempering. Once the path and plan are in place, the smart charge car will deliver the workload from step to step without the need of human interaction. Implementing an automation system will affect your business in many positive forms, including reducing the risk of accidents, improving quality control, increasing production, and optimization of manpower. Discussing automation should also include some initial discussion of controls and the layers in the automation pyramid. A typical automation pyramid for industrial applications includes a field level, a control level, a supervisory level, a planning level, and a management level. On the field level, we find devices connected directly to the processing equipment. The field level includes sensors, actuators, valves, and any other device used for controlling the equipment or collecting data from the process. Thinking back to the handling systems, the furnaces built 60 to 70 years ago operated on the field level only. There were no programs and no second level of automation. The next level is the control level. This would include PLC hardware and the software program. The interaction from the field level and the control level allows for mechanical motions to occur along with the process control of the temperature and atmosphere to create complete thermal recipes. The marriage of levels 1 and 2 is an improvement similar to the addition of a rear handler on a BIQ. It makes processing repeatable from one load to the next. The third level up is the supervisory level. This level includes the supervisory control and data acquisition, or also known as the SCADA system. Anyone in the heat treating industry knows SCADA systems are a must, as industry standards such as CQI-9 and AMS 2750 require strict record keeping of process-related data. A non-automated batch integral quench furnace line would include the bottom 3 levels of the automation pyramid. Adding automation to a batch integral quench furnace line includes the 4th level in the pyramid and ties the bottom 3 levels of the pyramid together. As we mentioned previously, the automation includes a plan for the entire thermal treatment from preheat all the way through the temper treatment. Once programmed, the plan is executed while capturing the data and process parameters throughout each step. This includes data collection from instruments at the field level, tying them to a load recipe run in the control level, and transferring the information to the SCADA system. This allows a heat treat facility to plan and provide a reliable, repeatable process flow of work while capturing all records along the way. The top level of the automation pyramid is the management level ERP system. Although this is not part of the conversation today, the next step and long-term goal would be to tie the automation system into a plant-level ERP system. Now that we have reviewed the handling systems in the automation pyramid, we will focus on the advantages and improvements automation will bring to your facility. Number one on the list is safety, as safety should always be in the forefront of any manufacturing facility manager's mind. The National Safety Council estimates work injury cost and time lost equal to $170 billion in 2018. Accidents requiring a medical consultation cost an average of $41,000 per person cost, while the cost for a life was found to be approximately $1.1 million. There were 70 million man-days lost in 2018 due to injuries. Removing humans from areas of risk reduced the chance of injury. In a heat treating environment, eliminating the need for workers in the furnace area and eliminating the need for an operator to load and unload the furnace greatly reduces the chance of an injury or accident. Pressure fluctuations, load transfers, and even the basic loading and unloading of a BIQ furnace requires awareness and education to avoid missteps and accidents. The cost of one serious accident involving a worker is greater than the cost to include automation in the next batch integral quench furnace line. The second major improvement that can be achieved by including automation is quality control. An automation system will allow the heat treat process plan to control the workload from entry to exit. The following is a report generated from an automation system installed in 2014 and still running today. Working with a SCADA system, a complete load production report lists the part number, description, and other information as the workload tracks through the heat treatment. In this case, a workload was washed in washer 1 and then sent to draw 4 to be heat treated to 700 degrees. All timestamps, temperature statistics, and alarms are recorded for future retrieval. The load then transferred to all-case BIQ furnace 3 for further heat treatment, again recording all process data, including temperature and atmosphere graphs. The load continued on through a post-wash, inspection, temper, and rust-prohibitive dunk tank. At the conclusion of the heat treatment, a report can be generated with all of the critical data captured in one place. Metallurgical data, process, and load sizes can also be input into the report. No steps will be missed, and no recipes will be misentered in the individual controllers. Another advantage of automating a furnace line is increased production. Much of the drive to automate furnace lines was done by captive heat treating shops, processing the same loads over and over again. Automating the process allowed for optimum production while reducing the manpower required. The production advantages can be realized at the commercial heat treat facilities as well. With an automated charge car, idle loads are eliminated as the loads are transferred as soon as the next piece of equipment is available. No more waiting during shift changes, bathroom breaks, lunchtime, or smoke breaks. Workloads can be built up and staged for multiple furnaces and process steps. A first shift workforce can provide enough stacked loads to run through skeleton crews in the second and third shifts. The 10-minute smoke break, plus the 15-minute shift change, plus the 5-minute bathroom break can add up over the course of a day or week. The additional time gained can result in an additional load making it into the furnace, providing extra income in the long run. One extra load per week over a 50-week work year is enough to pay for the automation. Another advantage achieved by automating a batch integral quench furnace line is the optimization of manpower. Time once used in moving workloads from one piece of equipment to another can now be used to build more workloads, perform routine maintenance, part testing, or other required tasks. The skill set of a load builder may not be the same skill set as a furnace operator or the supervisor of the area. Automation provides a tool to optimize the talents of the workforce and time available for the task required to run production. Whether you are looking into automating your BIQ line or not, the advantages achieved by doing so should be considered. Making your facility a safer environment to work in will prove to be more profitable in the long term by avoiding costly accidents. Allowing the programmed automation system to control the path and recipes of the entire thermal process while capturing all data required by your customers should be the ultimate goal of quality control. Utilizing your equipment to its fullest extent with the greatest production utilization means maximizing the profit available from your equipment. These subjects, along with the optimization of manpower, can be achieved more easily with the implementation of automation on your batch integral quench furnace line. Thank you for tuning in to watch and listen. Should you have any questions, please feel free to contact me at the email on the screen or call me at 419-891-1487.